Okay, in this video, we're going to expand on what we built in video 4, where we were dealing with PCV lines, or splines, curves, PTP, and len movements. Now we're going to expand this to incorporating tools and custom tools. So we've only been dealing with the flange here. You can see this X, Y, Z, I guess crosshair, of the flange, and that would follow the path, right? So what if we want to consider a tool, like the vacuum gripper or a welding tip or something? I don't think you're welding with any of the UFactory, but maybe. But we need to determine, or we need to tell the toolpath planners what that offset is of the tip so we can make tool pathing for it. So I'm going to reuse what we built in 4, and I'm going to clean it up a bit. We're going to stick with just len movements. It's simple, straightforward. So I'm just going to delete that, there. And we can also get rid of merge and reduce. We'll just drag this straight into T. One thing I just realized, I don't know if I did both in the first video or prior video of 4, is I see I divided the curve up by distance. I think in the video I was talking about dividing it by random points. So like I mentioned 10. So this is the tool I wanted to use, and I can't remember if I swapped it out to make a point or not. But the curve that we have, I'm just going to divide into 10 points. It looks like here I was dividing into every 5 mil, so it created many more points. Anyways, doesn't really matter. We just need some points to drop our XY plane on. I'm going to tighten up things a little bit. And I'll just leave everything as default right now. All right, so if we want to add a custom tool or a tool, we'll click on Egret, we'll go to Tools, and we'll hit Tool. There's a description on what exactly it does, but right away you see we have a bunch of options to populate. If you're familiar with making tools or TCPs in the past, you see that we have X, Y, Z, ABC values, and a weight, but we can touch that in a second. Let's go ahead and drag the T into tool. So that's going to take the existing tool path, and now we want to consider any offsets our tool may have so that we can put it into the output of stage or input of stage so we can output tool pathing. Right now, you saw nothing changed, but maybe I want to use my Lite 6 vacuum gripper, and you can see that my TCP of my robot is down here, but my flange of the Lite 6 is up there. We can make this actually easier to see by dragging the M, which is the tool mesh, into the tool component of stage. Again, that is just giving a visual representation of what the tool looks like, and it considers the TCP. Maybe I have the gripper, you can see it updates. One thing to note about Lite 6 and versus the other arm, the Lite 6 is the smallest one, but maybe you have, we'll switch back to vacuum. Maybe you have the, I don't know, xArm 5. You notice the tool path or the mesh changed, but the TCP is still at the tip of the robot. If we hide this, you can see the mesh of the tool we want to use. So if you had a custom mesh, you want to align it so it's in the origin of the XY plane, and it gets mapped to the end of the robot. All right, I'm going to switch it back to the Lite 6 because that's what I have. And you'll notice that I have the Lite 6 mesh version. If I switch to a different one, it's going to swap it. But if you have your own custom tool, you can generate your own custom mesh and drag it into here, into this M, and then it will be considered. But if you do that, you still need to define XYZ ABC. For the UFactory tools, I've already built it or baked it into the offsets. You see for this gripper, the offset is 61.1 in the Z domain. If you want to make your own custom tool or want to check existing tools, you can go to the UFactory UI and go to the Settings tab and select your current payload. You can see this is the gripper. I'm using the vacuum gripper, and you notice it's 61.1 in the Z domain. I do consider the weight in here as well. We'll touch on that later. So like if it's 0.145 kilograms. And where is that? And I have 0.145 kilograms as well. If you have your own tool, you can create your own tool and you can go through the calibration process by UFactory and you'll get these new populated values and you would plug them into here. And it would be considered in your tool pathing and that you could play back on your machine. Again, we can output code in either G code or Python code. It depends on which you're more familiar with or which one you prefer. G code seems to be more universally adopted across, I guess, large manufacturing machines, not really industrial arms, but like CNC machines, lathes, type like that. So if you want to use G code, you can use the G code component or the Python. There is some things to note depending on the two. Make this bigger. Depending on your tool, we need to consider the TCP offset. This is fine. Inside Python, I am telling the robot controller the offset of the flange. So in our case, or my case, I'm using that vacuum gripper. We already looked at it was 61.1. So all tool residual code after this line, is going to consider this offset. If we use G code, it's a little bit different. You can either consider the offset or let the controller, whatever you're sending it to say a Haas CNC machine or whatever, or I'm sorry, whatever controller you have, maybe a Linux CNC. I guess you're using on Lite 6, but you can change how the G code is made. We can bake the two offset into it, so you can see the Z values change with or with this off baked on and off. If you read the description, it gives you a little bit more details, and there's a wiki page that I'm curating that explains this in more detail. But G code is a little bit of an oddball where we can bake the offset into the code, or we can let the host controller maintain it. Again, it's a little more advanced, and maybe you're running a different controller than what's on the Lite 6. Maybe you're sending through ROS or whatnot. But in the most simplistic terms, if you're using Python, this is already baked into it, and you don't need to worry about baking offsets on or in or out. I'm not going to expand any more on this video, but there's one thing to note. If you use the gripper and the vacuum, those are two-stage tools, meaning they can be open or closed, or the vacuum can be on and off. We'll cover multi-stage tools in a future video. For what it's worth right now, I just wanted to show how to do TCP offsets for your tooling. I will save this and also upload it so you can digest and rip apart this Grasshopper file and learn a little bit more on your own. Again, all these tools have kind of great descriptions on it. I'm always trying to explain or expand upon them to make them a little bit more user friendly and a little bit more hand holding as you learn it.